All right, so for simplifying each of these three radicals, you may recall that there are two main methods that people use for doing these. One method is you make a factor tree. So for like simplifying the root 200, you break that up into its factors. So we might go down like this. So I get 5 and 2, then 10 and 2, and then that becomes 5 and 2. And then we'd say then that is the square root of, write them all out in order. And then we circle the pairs. And remember, one number from each pair, everything we circle, goes on the outside. And anything that's left not circled, that goes on the inside. And so you can see that by doing that work, we end up getting 10 root 2, because we do the 2 times 5 on the outside. Now that's if you made a factor tree. There were a couple methods we did, though. Some of you are doing factor trees, and that's great. And some of you also are doing the biggest perfect square method, where we would say, what is the biggest perfect square that multiplies into 200 evenly? Well, it's 200, so 100 must go into 200. And so then, if I were doing it that way, I would write it out as the square root of 100 times the square root of 2. And then the reason why I look for the biggest perfect square is because I can take the square root of it now. The square root of 100 is 10. And so again, we end up in the same place, 10 root 2. And we repeat the process for the others as well. So like for 50, the biggest perfect square that goes into it is 25. So that ends up giving us 5 root 2. And then the 18, the biggest perfect square that goes into 18 is 9. So that would be root 9 times root 2, or 3 root 2. So that's each of those simplified. But really, this is actually just a preamble for today's work, because we are learning one new topic today, but actually you'll find that just because you can do that, it's hardly anything new at all. We're going to be looking at how we can add and subtract radicals. Now, if you wrote it down the way that I wrote down that first problem, all you have to do is write the subtraction symbol there and write the addition symbol there. Because right now we cannot add or subtract them with the way they're currently written, because they're not like terms. We don't have the same stuff inside the radicals. But if I simplify all of them, so notice all you got to do is carry down that minus and carry down that plus in the work we showed earlier. Now you'll notice, now that they're simplified, we have root 2, root 2, root 2. We can combine those. So up here, we cannot combine them from that form. But if I simplify them down and find that they do have the same square roots in them, then I can add them and subtract them. So I have 10 root 2's, and I take away 5 root 2's. That's going to leave me with 5 root 2's. And then if I then add 3 root 2's to the 5 root 2, I end up with 8 root 2's. And so that's our answer here, 8 root 2. Then I want you to notice here that I could not have just started this problem by going ahead and just adding and subtracting the numbers on the inside. If I did 200 minus 50 plus 18, that would give me 168. The square root of 168, if you try to simplify it or even plug it in your calculator, you will find that that does not equal the same thing as 8 root 2. So I just want to make it clear that you actually have to do it this way in order for it to work. Okay, now, there's one other type of problem that we're doing for the first time today, but again, it's following very much on the heels of stuff you already know how to do. So please write down this problem, and heck, you could probably even just go ahead and do it from here. Because we know that if I'm multiplying binomials, I need to multiply everything in the first parenthesis by everything in the second parenthesis. So I'd start by doing the 5 times the 7. So that gives me 35. And then we do the 5 times the 2 root 3. Now, when multiplying them, whatever's on the outside multiplies with whatever's on the outside. So in this case, that means I'm doing the 5 times the 2 to get a 10. And whatever's on the inside of the radical multiplies with whatever's inside the radical. Now, in this case, that root 3 is the only one involved. so it's not going to change. It's just going to stay a root 3. Okay, then we continue on from there. I'm now going to take this root 3 times the 7, which will give me 7 root 3. And finally, we do the square root of 3 times 2 square root 3. Well, the 2, notice, is the only number on the outside, so it's just going to stay a 2. But then I do root 3 times root 3. Root 3 times root 3 equals what?
Root of 9.
The square root of 9, yes, which equals 3. And so that last term is really just going to be 2 times 3. From here, it's just a matter of cleaning it up, right? So go ahead and then combine the like terms. And so really that 2 times 3 is just 6. So now when I start looking to combine like terms, you'll notice the 35 and the 6 will be able to combine. So that's going to give me 41. And then the 10 root 3 is going to be able to combine with the 7 root 3. And so when I combine those, that's going to give me 17. Now remember, they have to be like terms for us to be able to do this. They have to have the same radical. And anytime two things have to be the same, that's because it's going to stay the same. So that's why it's still a root 3. This then would be your final answer. So this problem is on the more complex side. So if anything's going to get you hung up, I would hope that it'd be at this level, although hopefully not even this. But, these are still tougher ones. Now, again, there's multiple ways you can start one of these more complicated ones. But I'm going to go ahead and start it with my preferred way, because whenever I see parentheses all to a negative exponent, the very first thing I do is I deal with just that negative exponent. And so I'm going to do that, just because that's become my habit. I find that makes my life a little bit easier if I do that. So the only thing I'm doing is I'm changing the negative 3 into a positive 3. That means I'm dealing with the negative. What does the negative do to my fraction? It flips it, exactly. And it flips everything inside of it. It does nothing else, but it flips everything. So what was on the bottom goes to the top. Notice that's numbers and x's. Everything that was on the bottom goes to the top exactly as it was. Then, what was on the top is now on the bottom. Again, exactly as it was. No other changes made. By doing that, I just avoided a whole slew of possible errors that come up. Like, I've seen people that recently have been trying to do, I'm just going to make this faster. I'm just going to deal with the negative 3 all at once. Invariably, this 2 messes them up. And so, seriously, deal with the negative, then deal with the 3 whenever you're doing that. All right, now again, I have an option about what I want to do next. I can either go ahead and cube everything on the inside, or I can simplify my fraction. And again, there's nothing magical about which one you do first. It's a personal preference thing. What feels most comfortable to you? For me, today, I feel like simplifying the fraction first. So I'm going to do that. All right, so in order to simplify that fraction, that means that the whole thing is still going to be cubed, because I'm not touching that yet. On the top, I still have the 2. Notice that I do have this negative exponent here. So I'm going to go ahead and just move that down to the bottom. I'm going to deal with that negative exponent. And so then it's going to be 2x squared left on the top, and that's it. On the bottom, I still have the x cubed. I still have the x to the 8th. But now I also have the x to the 9th down there. By doing that, it just makes it that little bit more comfortable. And so then I now have 2x squared over, now I'm going to go ahead and add those exponents there. So x cubed and x to the 8th gives me x to the 11th. X to the 11th times x to the 9th, I add those exponents, that gives me x to the 20th. And again, there's nothing magical about the order of these. Like when I did this problem yesterday, I actually started by adding those and adding those. And then I simplified after that. Either way, it's going to work, okay? Just as long as you're following the rules and truly doing just one thing at a time, you'll be fine with these tough ones. It's when people try to like cut corners, make things faster, that's when the wheels come off. All right. So before I cue it, I still can simplify the inside of that fraction just a little bit because I see this x squared over x to the 20th. And so then my 2 is still on the top, but if I do the 2 minus 20, because I'm dividing the x's, so I subtract the exponents, 2 minus 20 gives me negative 18. When I see negative 18 in my exponent, that tells me that I'm going to have x to the positive 18 in the bottom. Whenever you see that negative exponent, it tells you it's in the bottom of the fraction like that. Now there's nothing else I can do on the inside of this. Remember, I decided to simplify the inside first. I've now done as much as I can in that regard. So now I have to go and deal with the cubed on the outside. All right. So that means that on the top, I'm going to be doing 2 cubed. Notice it's not 2 times 3, it's 2 cubed, which is 8. And then on the bottom, I'm going to do x to the 18th cubed. Now when I do a power to a power like this, what do I do with the 2 exponents? We multiply them. And 18 times 3 gives me 54. That then is the final answer. That's as good as we can make it and as far as we can go there. Right, now when starting this one, probably about the most complicated you might ever have to deal with here, you actually have, again, a couple options about how you want to start it. The most straightforward way would just be simplify the radical on the top, which would mean simplify the square root of 72, simplify the square root of x to the 13th, and simplify the square root of y to the 6th. And then you do the same thing on the bottom, simplifying that radical. And that is good and that is fine. But it's not the only way that you could approach it. Another way that you could approach it, because both the top and the bottom are square roots, is you could actually just put one big old square root over the fraction and then simplify the fraction first. So what I would do if I were in your shoes is I would take a look at these two. Which one do you find easier? Do you find it easier to just simplify that radical and all of its stuff inside, or do you find it easier to reduce that fraction? Whichever one seems easier, go from that point. All right, so let's take a look at how you would have done either of those. If I were doing it on the left-hand side, I'd start by simplifying the square root of 72, which would give me 6 root 2, because root 72 becomes the square root of 36 times the square root of 2, and the square root of 36, of course, is 6. Then I would simplify the x to the 13th. X to the 13th, the square root of that means that that's actually x to the power of 13 over 2. This is an important type of problem to be able to do. All right, I then take my 13 halves and I turn it into a mixed number so I know how many wholes I can pull out of this square root. 2 goes into 13 6 whole times with half left over. Therefore, the square root of x to the 13th would be x to the power of 6 times the square root of x. So notice, power of 6, that's the whole number out front, and then whatever the fraction is, that of course becomes a radical there. And then you would continue repeating that exact same process for all the rest of the pieces. But since all of the rest of the work would basically be the same idea, I'll go ahead and gloss over those for the moment. If you're doing it with the method on the right, you are simplifying the fraction first. And so that means that we know that our next step is going to be a big old square root still. It's just a matter of figuring out whatever's inside. So I'd simplify 72 over 4, which is 18. Then I'd simplify x to the 13th over x to the 6th. I'm dividing x's, which means subtracting their exponents. So that would give me x to the 7th. And then the y to the 6th, there's no y on the bottom to change that. So that's going to stay y to the 6th, which means that all this would actually just be over 1. So we don't really need to write over 1 though, do we? We could actually just write it as a square root. So whichever way you did it, this is your next line of work. Now notice, whichever way you chose to do it, you eventually have to use the other skills as well. So like on this one, we started by simplifying our radicals. On this one, our next step is to simplify the radicals. On this one, we reduce the fraction first. On this one, the next thing we do is to reduce the fraction. It's just a matter of doing whatever you find most comfortable first, mainly because at the start, they're bigger numbers to deal with. But it's the same principles involved for working with it from there. So on the left one, we reduce our fraction, so the 6 over 2, that's going to reduce. The x to the 6 over x cubed is going to reduce, and then the y will stay the same. On the right side, we'll again simplify the square root of 18, which becomes root 9 times root 2, so in other words, that's 3 root 2. The x to the 7th becomes x to the 7 halves, because it's the square root, and so that is x to the power of 3 and a half. So in other words, x cubed root x. And like finishing it off here this time, the square root of x of y to the 6th, that'd be y to the power of 6 over 2. Well, 6 over 2 is just 3, so that would just be y cubed for that part. So either way you do it, you end up with the same solution, 3x cubed y cubed times the square root of 2x.